Hello students of class 7, once again I'm Sudhir and welcome back to my video. In today's video I'm going to uh, highlight the solutions of the exercise 6.5 and also the last topic of the chapter, that is right angles, triangles and the Pythagoras property. So this is the last topics of this chapter number 6, and we are going to study here about the right angle triangles and the properties of Pythagoras theorem. So one theorem is there where it is only to apply in a kind of triangle that is called right angle triangle. We all know that is a right angle triangle is a triangle where you can find that one of the angle is 90 degree, isn't it? So for that kind of triangle only this Pythagoras theorem is um, really means for can use there in order to solve our solutions or in order to find out the unknown measurements of the size like it. Okay, so here let us try to understand what is Pythagoras theorem and what is the right angle triangle. First of all, let us see. And uh, the right angle triangles, their sides are having some special names. The names of the sides are given as other names, so that uh, we are going to know it first. Okay, so once again I'm going to show you that the special names of the sides of the right angle triangles. Okay, so let us start here. So Pythagoras is a Greek philosopher of 6th century BC. He is said to have found a very important and useful property of right angle triangle given in this section. The property is hence named after him, so that's why it is called Pythagoras property or Pythagoras theorem. Okay. In fact, this property was known to people of many other countries too. The Indian mathematician Baudian has also given an equivalent form of this property. It means, say, first of all, this Pythagoras. Pythagoras is actually is a name of person. He was a Greek philosopher of the 16th century BC. There he used to found a very useful property uh, that is widely used by the people of this world today. It means in different country. And this property again, what happened after he discovered this property? This property is again explained by our Indian mathematician called Baudian. Okay, with the same uh, theory, with the same concept, but in a different way he used to explain that actually it is in our book, but here is the content is not being mentioned. That if I have another time, then I will show you. But you also should know that how Bodhian also explain the same theory, the same this concept of Pythagoras property. Okay, so next we now we now try to explain the Pythagoras property first. So to explain the Pythagoras property, in a right angle triangle, the sides have some special names like that. The side opposite to the right angle is called hypotenuse. Once again, in the right angle triangle, we have one angle that is 90 degree and that is called right angle, and in the opposite side, or the side that opposite to the hypotenuse, the side that is opposite to the right angle is called hypotenuse. So we will try to find out which one is hypotenuse. Okay, the other two sides, when the side opposite to the right angle is called hypotenuse, then the other two sides are known as the legs of the right angle triangle. And here is the diagram of the right angle triangle. ABC, the triangle ABC is right angle triangle and it is right angle at B. You can see that right angle at B. And AC is called the hypotenuse, and this is the side that opposite to the right angle. So this is called hypotenuse. And the other side, that is BC and BA, are called the legs of the right angle triangle. Now here in the given diagram, ABC is a right angle triangle. Now in this diagram, ABC is right angle triangle um, and right angle at B. Yes. Then AC is the hypotenuse, and BC and AB are the legs of the right angle triangle. Now let's go to the next part of the lesson. The next part of the topic is the Pythagoras theorem. So here we are going to start to know more about the Pythagoras theorem and how Pythagoras theorem been uh, what to say deduced, or how Pythagoras theorem has been formed, from where it used to become, and how we can prove it, the theorem. Okay, how we can uh, how we how we how we can derive the theorem, how we can derive the formula, that is going to be discussed here. Okay, so actually here in this topic, I am going to show you the derivation of the Pythagoras theorem or Pythagoras formula. Okay, so let us see now. To make sure and to make sure of the the proper derivation of the Pythagoras theorem, so let us understand some more points here. That is, make 8 identical copies of the right angle triangle of any size you prefer. So here we are going to do some small activity to derive the formula to deduce the theorem. Okay, see, we are going to see in here, it is explaining here, or is giving a statement that make 8 number of identical copies of right angle triangle, same size. Okay, right angle triangle. For example, you make a right angle triangle and say that hypotenuse is a unit. Once again, let us take that hypotenuse as a unit and the legs are of length b units and c units. Then draw 2 identical square on a sheet with side of length uh, b plus c. So b is the b and c are the units of the two legs unit, and a is the unit of the hypotenuse. Okay, how much long that hypotenuse, let us take as a, how much long the other two legs as b and c, and we are going to draw two square. We are going to make two square on the sheet. The square will have the side. Okay, one side means all the side will be same, so a side of which will be equal to the length b plus c. B plus c means together, b and c together. Okay, clear. Let's see how we can do it. You are to place. Now we are going to place four. See, we have to make 8 triangles in it. So we are going to place four triangles, the same four triangles in these two squares. It's or in this in its square. Okay, let's say square A and square B, whose length is B plus C. So we are going to place four right angle triangle that we make by cutting some paper or some chart paper. So I will show you here step by step. Okay, listen here. Once again, you are to place 4 triangles in one square and the remaining 4 triangles in other square. Means four we are going to place the right angle triangle. Those right angle triangles we make. Okay, but the way how it kept is going to show here in the diagram here. Now, my dear student, so let us think that the 8 copies of right angle triangle. Let us assume that this is the right angle triangle we are going to make. Okay, where the hypotenuse is A and the other two legs are B and C. So we are going to make the 8 of them. So think that you already made 8 number of such type of uh, triangle already. Okay, then we are going to draw a square A and square B here, square A and square B here. So here we are going to place four in such a way that we can derive the formula of the Pythagoras theorem. Or you can deduce the Pythagoras theorem here. So let us see the next how we can place here. So take one of them here, like this we place. Okay, one we get, four we have to keep here in the square A, and another we kept in such a way, and another, yeah, third one, four we have to keep it, isn't it, like in this way, and the fourth one in such a way. Okay, you see, we place the four right angle in such a way that all these hypotenuse means A, the side A. Now it makes a square, another square in blue color, isn't it? Square there. You can see that another square in blue color. That is uncovered area of the square A. Square A. Actually, it was just once again come back here like this. You see, it was a square, isn't it? So the square was placed with the four right angles in this way. Okay, like this one, two, three, four. So for the all A are facing here, and it makes one square there. You see, square where the side is A now. So the area of the square will be A square. Yes. Now next, how we place the other four triangle in square B is in this way. You see, one like this, another like this, again one like this, another like this. So we place in such a way, and you can see that there are another two smaller square in square B. That square with the side B and square with the side C, you can see these two are also square. The blue smaller square you can see there in B. So what happened, uh, the we are just using the same triangle, in the triangle having the same size only. Okay, we don't change any size or any side. Okay, so you see, the way we kept in A, we form the triangle where all the sides are A, bigger, we say the bigger square, isn't it? And the way we kept triangle in the square B in such a way that it make two another smaller square. One is with the side B and one is with the side C. See, I'm showing here only two sides. Doesn't matter two side or one side or all side. Doesn't matter, because square means that when one is B, then all will be. When one is C, all will be C, isn't it? Now, next, what we are going to do is here. Hence, the uncovered area of A. Uncovered area means, you see, some are covered with the red part of the uh, triangle, isn't it? And uncovered part, you see that blue part, that is the area. Okay, and then uncovered area of the B. So actually, that before, once again, let's come back to this point here. See, these two square are the same square only, it's identical. They are identical, they have same area. So area of the square A is equal to area of the square B now. Okay, that is what is meant here. Okay, once again, we can see here that how is this. Yes, now hence the uncovered area of the square A, area of the square A is equal to area of the square B, isn't it? Then it means that that is area of the inner square, blue area, will be equal to the total area of the uncovered blue squares in the square B. It's blue square you see here. Once again, see, we make the area of this smaller square and the bigger square in the A and B separately is with the same size and same type of right triangle, right triangle only, or right angle triangle only, isn't it? So what happened, that area will be equal. Therefore, so it is deduced that the area of uncovered blue square in A is A square. Area of this square where all the sides are A is A square. Means the area of the square is side square, isn't it? Side means here is A, so A square equal to the area of the uncovered square, that is blue in B. There is one is square, smaller square, or one square is with the side B. Then the area of this square is B square plus. Then the area of the another square that is with the side C is C square. So A square is equal to B square plus C square. So this is the formula, or this is the theory that is telling by the Pythagoras theorem. That means area of it means uh, square of the hypotenuse is equal to square sum of the square on the two legs. Two legs means B and C. You can see here in this small first red triangle here, one separate here. So here what happened? A is the hypotenuse and the B is the other legs, isn't it? B and C are the other legs. So square on the hypotenuse is equal to the sum of the square of the other two legs. So this is what the Pythagoras theorem tells us. Okay. Now let us see next. So it deduce from here we can conclude like that or deduce like that. In a right angle triangle, the square on the hypotenuse is equal to the sum of the square on the legs. So this is what the Pythagoras theorem is saying. So what do you mean by the Pythagoras theorem? Means the square on the hypotenuse is equal to the sum of the square of the legs. That's all. Okay, clear. So this is the Pythagoras theorem, and you must always remember that a square is equal to b square plus c square. So with this, let us go to the next part of the lesson. Now, next part of the lesson we have exercise 6.5. So we are going to start the exercise 6.5 with this Pythagoras theorem and or the property of Pythagoras. Okay, or we said Pythagoras property. Now, question number one of exercise 6.5. The question number one is saying like this: PQR is a triangle right angle at P if PQ is equal to 10 centimeter and PR is equal to 24 centimeter. Then find QR. Once again, yes. Now let us see. This is the let it be the diagram of this triangle PQR. So PQR is a right angle triangle and right angle at P now. So here PQ is given and PR also given, but QR is not given. So we are going to find out QR. So how we can find out the QR is that we are going to apply the formula, that is Pythagoras theorem or Pythagoras property. So Pythagoras property is telling us that the square on the hypotenuse is equal to the sum of the square on legs, isn't it? That means what is the uh, hypotenuse here in this figure, in this triangle? QR is the hypotenuse, isn't it? So square on the QR is equal to uh, square on RP plus PR plus or square on PQ. Let us see. In the solution we have like this: using the Pythagoras theorem in the right angle triangle PQR, we have QR. QR square is equal to PQ square plus PR square. That means implies that QR square is equal to 24 square. So PQ you can see that PQ is not PQ. See a PQ and QR. Okay, that's what we need. Now let us see again. Uh, Using Pythagoras theorem in the right angle triangle PQR, we have QR hypotenuse is the QR. So QR square is equal to PR square plus PQ. Then means implies that QR square is equal to 24 square plus 10 square. So PR or RP, doesn't matter, PR or RP is 24 centimeters, so square on it plus uh, plus 10 square. Okay, PQ is 10 centimeters, so 10 square. So after that, how much we get here? Let us now implies that QR square equal to 24 square. We have 576 plus 10 square is 100, and what if we add, then we get here 676. So QR square is equal to 676 we get. At the next step we have like this QR. So QR is having square on it, but now that square is transposing to the other side. When we bring this square on the other side, this square will become the square root. This is called square root. Okay, so how to find out the square root, I will just tell here. Next, what we have to do is that we are going to factorize. We are going to find out the prime factors of this number 676. Okay, that is we are going to prime factorize it. How we do, let us see next. See, this is how we factorize, and we got here 2, 2, 13 and 13. These are the prime factors of this number 676. Then how we can write the next step? You see here, QR is equal to root over 2 into 2 into 13 into 13. So these are the prime factors of 676. Then next we can write as QR is equal to root over to the power 2 and 13 to the power 2, means 2 square and 3 square. So the square and square root can be cancelled here. By cancelling the square and the square and the square root, we get here like this: QR is equal to uh, 26. 13 twos are 26, isn't it? We get here 13 twos are 26. So we cancel square root and square. We get here 2 into 13 only. Then we get here 26 centimeter. So QR is 26 centimeter. Now we got the answer that QR is equal to 26 centimeter. And next we have another question number 3. Okay, after 1 I come to 3 because 2 I'm giving you for your practice. I'm keeping you for practice. I'm leaving this for your practice. Okay, in question number 3 we have like this: a 15-meter long ladder reaches a window 12-meter high from the ground on placing it against a wall at a distance. Find a distance of the foot of the ladder from the wall. Just imagine that at a certain height, one window is there. In that window, you keep a ladder. So you keep a ladder in such a way that you can climb. You don't keep the ladder uh, just on the wall, isn't it? That you don't keep just on the wall. You have to bring the foot little away from the wall, isn't it? So that distance of the foot of the ladder and the wall, we are going to find out. So we have to draw the structure now: the ladder, the wall, the ground, and the window here. So let us see. This is the diagram given in the question that uh, A, B, C. So let A be, be the ladder, and B, C be the wall, and the B is the window. Then AC is the distance between the ground and the sorry, distance between the wall and the foot of the ladder. So that we are going to find out AC. See, hypotenuse. This is also right angle triangle because always a wall used to be stand upright, isn't it? Perpendicular to the ground, the floor, isn't it? So here the right angle is at C. We should understand that the right angle is at C, and the side of the right angle AB is the hypotenuse now. So we have to apply the Pythagoras theorem here also. So let us see how we can solve this problem. Now in solution, let AB be the ladder and the B be the window. Then AB is equal to 15 centimeter and BC is equal to 12 centimeter is given there. Then since triangle ABC is a right angle triangle and right angle at C, then AB is hypotenuse. Square and hypotenuse is equal to the sum of the square of the other legs, isn't it? That means square of the hypotenuse is AB square equal to AC square plus BC square. Yes. Next, after that, implies that AB is 15 meter. Okay, so AB in place of AB, let us take this 15, which is the value of AB. Isn't it? Every value is 15, so 15 square equal to AC square. AC is to be find out. AC is unknown there, so AC square. So AC square plus BC is having the value of 12, means the height of the wall is 12 meter, isn't it? So we are taking the value of BC as 12 meter or 12 and square on it, isn't it? That means 15 square is equal to AC square plus uh, 12 square. Then what we get next, let us see, implies that see we are going to find out the AC. So keep the AC on each side. Keep the AC here and bring this plus 12 square on the other side. Then it becomes minus 12 square. So AC square is equal to 15 square minus 12 square. Then we get here in this way that AC square is equal to uh, 225. 15 square is 225 and minus 12 square is 144. 144. Clear? See, square means we have to multiply the same number 15 into 15. Here 12 square means 12 into 12. So 15 to 15 is 225 and 12 12 are 144. Once again 15 square means 15 into 15, there is 15 15 are 225 and 12 12 are 144 here. So AC square is equal to 225 minus 144 and we get AC square as 81 here. Still we don't get the answer as 81. Something needs to do because on AC you see square is there. So this square we have to bring on the other side where there is 81. So after bringing that, what happen you see, when we bring this square on the other side, then the square become the square root now again. So we have AC is equal to root over 81. Root over 81. We have to pronounce this as root over 81 here. Then after that we can see like this, AC is equal to root over 9 square. 81 is 9 square. Once again 81 is 9 square, this 9 into 9, 9 9 is 81, isn't it? 9 and 9 are multiplying, that means it is 9 square. So here again the square root and the square can be cancelled. We can cancel these two and then we have here AC is equal to 9 and it is meter because it's given in meter already, isn't it? So it is 9 meter now. Hence the distance of the foot of the ladder from the wall is 9 meters. So here we get the answer of the solution. So then we go to the next question here. Next level of the question is question number uh, 4. But before that, please, dear student, question number 2 is your homework. Please do it, all of you. Okay, it's very simple. You just see, you can find it. Okay, very easily. Very simple question only. That's why I'm leaving for you. Try it. If you are not able to do, you can just ask me. Okay. Then let us go to the next question. The next question is question number. We have question number 4. In question number 4, we have a question like this: which of the following can be the sides of the right triangle? Here, three questions are given here. Three options are given here. From there, we have to find out which sides are are to form or can form the right angle triangle. Means if the three sides given there, the three measurements, let us see the question here. Yeah, Roman number 1, Roman number 2, and Roman number 3 here. So what happened? We see which of the side can be the side of the right angle triangle. So let us see which of the 1 or 2 or 3. Okay, clear. So here for this answer we have here like this: in the case of the right angle triangle, identify the right angles. Now actually here these three questions are there, and three questions I will only show you only one here, and the rest are same only. In the same way, you can just follow it. Okay, and the question is asking again, in the case of the right angle triangle. So we are going to find out which is right, which one, I mean Romano 1 or 2 or 3 are the right angle, can be right angle triangle or not. If right angle triangle, then we are going to find out where is the right angle again. Okay, clear. So that I will show you the answer as like this. The solution, yeah, let A, solution I'm showing one here. So let A be 6.5 centimeter and B be B is equal to 2.5 centimeter and C is equal to 6 centimeter. So three measurements are given here. One you can see in the Roman number 1 EM, not EM, maybe CM, okay, centimeter. So my dear student, you see here that these three measurements, they are the sides of the triangle, and we are going to find out whether it's a right angle triangle or not. Okay, clear. And if it is right angle triangle, then where is the right angle also we have to say. So first of all, what we have to do is that let A be the hypotenuse and the B and C be the other legs, as we have just gone through, isn't it? So let us take this A as the longest side. The longest side here is 6.5 centimeters, isn't it? So always hypotenuse. See, one thing, my dear student, you must keep in your mind that hypotenuse is always longer than the other sides. Okay, hypotenuse is always longer than the other two sides. So longer one you take as hypotenuse, and we have to square on it, and we must put equal to, and we have to add the square of the other two legs, that is B and C, isn't it? So let A be 6.5 centimeter, B is equal to uh, 2.5 centimeter and c is equal to 6 centimeter. Then let us see what we have. Then by Pythagoras theorem, we have this. Therefore, a square is equal to b square plus c square. So this is what the Pythagoras theorem means. Isn't it? It means square on hypotenuse equal to square sum of the square of the other legs. So if these values are same, then it is right angle. And where is the right angle, that will tell. Okay. Now next we have like this. A square. A is 6.5 centimeters. So we take this 6.5 and square on it, and b is 2.5 and c is 6, so we square on their values. Now on the left hand side you see it is 6.5 square, and on the right hand side it is the sum of the square of the other leg, that is 2.5 square plus 6.6 square. Now next, yes, the value after we calculate, after we multiply 6.5 two times, okay, we get 42.25. The square of 6.5 is 42.25, and equal to, okay, and equal to, and is equal to uh, 2.5 square is 6.25 plus 6 square is 36. That means 6 6 the 36, isn't it? Then we add the other side. So after we add on the right hand side, the hand side also 42.25, and the left hand side also 42.25 to 25. So both the side are equal, and it holds the equations is correct. The equation that given by the Pythagoras theory is correct, or Pythagoras property is correct. That means it is, yes, it is Roman number one is a right angle triangle. And where is the right angle? Here we'll find here, we'll show here the right angle, and thus the side can be the side can be the right angle triangle. Yes, the sides given here can be right angle triangle, and the right angle is opposite to the side of the length 6.5 centimeter. Once again, the 6.5 centimeter is now as the hypotenuse, isn't it? Then the angle which is opposite to this side is right angle. That's all. Okay. In this way, please try the other two also to get it. Okay. And if it is possible, you do it. If you cannot, you can ask to. Okay. The other two are same way only to do. Okay. So next, yeah, dear student, question number 2, question number 3, and question number 5 is your practice. So they are all uh, same to one another. The way we prove, the way we solve it out, okay, will be the same as now in this question number 4. So please do it yourself, try yourself, and uh, just test yourself whether you understand something or not. Otherwise, you can ask me. Okay, you just uh, try to consult with me, okay, of your problem. So here are the some problem that you practice, and you try to understand the whole concept. Okay, next question we have question number 6. In question number 6, it is saying that angle q and one number 2 of APQR are 25 degree and 65 degree. Okay, see my dear student here. Yes, here, see my dear student, we have question number 6. In question number 6 is saying that angle Q and R of a triangle PQ are 25 degree and 65 degree. So write which of the following is true. So here you can see some more questions there. PQ square plus QR square is equal to RP square, or PQ square plus RP square is equal to QR square. So three questions are there. Of these three questions, we have to find out that which one is the correct statement, like true or false. Here we will have the diagram also. See, this is the diagram of the triangle PQR. PQR. Okay, clear. So diagram PQR. Now we don't know where is the right angle and what type of triangle is that, and what these statements are telling, and which one is correct, we don't know. So first of all, to understand the questions, what we have to do is that we have to find out the third angle. Two angles are given as 25 degree and 65 degree. So one angle is not given, so one angle we have to find out. How we can find out is showing here. Now in the solution we have like this. By the angle sum property, we have angle P plus angle Q plus angle R is equal to 180 degree. Yes, angle sum property, we have studied that the sum of three angles is 180 degree, isn't it? So the sum of PQR, angle PQR will be 180 degree. From there we can find out the angle P, that is angle P plus Q is 25 degree and the R is 65 degrees, isn't it? So angle P plus 25 degree plus 65 degree is equal to 180 degree, and implies that angle P plus 90 degree. Angle P plus 90 degree, that is equal to 180 degrees, isn't it? Now we get here angle P is equal to 180 degree minus 90 degree, then we get here 90 degree. 90 minus 180 degree will get 90 degree, that means angle P is 90 degree. Now means this is a right angle triangle and right angle at P now here. Okay, then why we have to find out the right angle, where is right angle, is because the side opposite to the right angle is hypotenuse. So we have to be very careful and we have to understand that the side, which side is equal to the which side is opposite to the right angle. Okay, now QR is now opposite to the right angle P, then QR is hypotenuse. Then which one is the correct one? You see here PR or QR. QR is hypotenuse. QR square. Yeah, here QR square is equal to PQ square plus RP square. RP square. Yes. Then 2 is true. Yes. Therefore, triangle PQR is right angle triangle at right angle triangle or right triangle and right angle at P. And by the Pythagoras theorem, it says that P PR square plus PQ square is equal to QR square. That means hypotenuse is here and the other two legs are here. Okay, doesn't matter that we change the side, but it is the Pythagoras property only. So the Roman number 2 is holding good the property of Pythagoras. So number 2 is the correct one. This is the answer of question number 6, and let's go to question number 7. Now we have question number 7. In question number 7, it is asking that find the perimeter of the rectangle whose length is 40 centimeter and the diagonal is 41 centimeter. So we will draw the rough sketch first. Okay, clear? Next, this is the rectangle ABCD and the length is 40 centimeter. Length of the rectangle is 40 centimeter and its diagonal is 41 centimeter. And we know that the rectangle is having angle of 90 degree. That is, right angles are there, isn't it? So the angle B is right angle and AC is hypotenuse now. So we are going to find out the BC. Yes. After finding the BC, we have to find out the perimeter of the whole diagram, the whole rectangle, isn't it? If we know the breadth, we don't know the breadth, we know the length, isn't it? We need the breadth to find out the perimeter. So to find out the breadth, we use this diagonals, and diagonals now is as the hypotenuse. So here we can apply the Pythagoras theorem and we can find out the BC, which is the breadth of the rectangle, and we can find out the perimeter. So let us see the solution. In the solution, let ABCD be the rectangle such that AB is equal to 40 centimeter and AC is equal to 41 meter. Sorry, 41 meter and 40 meter. Okay, AB is equal to 40 meter and AC is equal to 41 meter. Now, here, my dear student, is given centimeter here. Just 1 minute. Yes, my dear student, we have centimeter, not meter. Okay. So in the solution, let ABCD be the rectangle such that AB is equal to 40 centimeter and AC is equal to 41 centimeter. Then what we have, let us see, in the right angle triangle ABC, right angle at B, by the Pythagoras theorem, we have that. Oh, this right angle triangle ABC, we get right angle triangle ABC here by the diagonal, isn't it? And it is and the right angle is at B now. So then AC is the hypotenuse. So we can apply the Pythagoras theorem to find out the BC now. So BC, what is the BC? BC is the breadth indeed, okay, of the rectangle. So we need this BC to find out the perimeter of the rectangle. So by the Pythagoras theorem, we can find out the BC. So let us see how we can do. Then we have that BC is equal to AC square minus AB. My dear student, actually this is AC square is equal to BC square minus plus AB square. So what happens if we bring AB square on the other side where AC square is there, the hypotenuse, then it should be minus. Plus will become minus. Okay. Actually, it is AC square is equal to BC square plus AB square. So AB we are bringing to the other side where AC square is there. So it will become minus. We change it. Okay, clear. Then what we have, you see, BC square. BC square is equal to 41 square minus 40 square. AC is 41 centimeter and AB is 40 centimeter. So we have to subtract their square, isn't it? 41 square minus 40 square. Then how much we get here? You see BC square is equal to 1681 minus 1600. I mean 1600. Once again, square of 41 is means 41 41 1681 minus 40 square 40 40 is 1600. Clear. So we have to subtract this, and we find out, let us find out how much b square is. Now the b square is getting here as 81. Here we get here b square as 81. Then we are we are having something to do here. That is, we have to find out the BC, not the BC square, isn't it? Yeah, BC. So we BC we get here as root over 81. So B square, BC square. So this square, if we bring on the other side where 81 is there, then this square will become as root square root. So it is root over 81 now. Root over 81, what will be the root over 81? Let us see. Now BC is equal to root over 81 can be written as 9 into 9. 9 9 is 81, isn't it? Yes, then BC is equal to root over 9 square now. Now we can cancel, we can cut the square root and the square now. By cancelling this, we get here only 9 here. So we got BC is equal to 9, which means 9 centimeter. Now we get the BC, the breadth of the rectangle, as 9 centimeter. Now we can find out the perimeter. Thus, now the perimeter of the rectangle is 2x L plus B, that is 2 into 40 centimeter plus 9 centimeter, that is 2 into 49, that is 98 centimeter. So the perimeter is 98 centimeter we got now, isn't it? So this is the answer of this question number 7. And with this, let us go to the next question. Next question, we have question number 8 here. My dear student, you see question number 8. In question number 8, the question is the diagonal of a rhombus means 16 centimeter and 13 centimeter. Find its perimeter. Now, this is the rhombus now. So this is the diagram of the rhombus A, B, C, D. So two diagonals are given here, AC and BD here, and they are intersecting at O. Okay, clear. So let us see how we can solve this solution. Already I have given here the solution. In the solution, we have like this. Let ABC be the rhombus such that AC is equal to 30 centimeter and BD is equal to 16 centimeter. Okay, it is given there in the question itself, isn't it? Then therefore, okay, therefore in the triangle AOB, just see here, the triangle AOB, AO, AO is equal to half of AC. How about AC? Why? See, one thing you must understand, one thing you should know, that the diagonal of the rhombus is bisecting each other. Once again, the diagonals of the the diagonal of the rhombus is bisecting each other. Okay, bisecting each other means they cut into equal halves. Means AC will be into equal halves. AO is equal to OC. Here also BD will be equal to uh, OD plus OB. Means OD and OB will be equal half. They make equal halves. Okay, by cutting here at O. Means the diagonal of the numbers bisect one another. Okay, that's why here saying that AO is equal to the half of the AC. now equal to half of AC. What is the AC? Given here AC is 30 centimeter. How 30 centimeter is 15 centimeter. Now we get AOS 15 centimeter. AOS 15 centimeter, and again you can see there here OB. Okay, OB. OB will be the half of BD. You can see one triangle here, triangle AOB. So this AO is a half of AC, that is 15 centimeter, and the OB is a half of BD, which is half of 16 centimeter, that is 8 centimeter. Now AO is 15 centimeter, and OB this side is as 8 centimeter we get. Now we are going to find out AB, isn't it? Yes. So now again in the triangle AOB, AOB, you see AOB. Okay, AOB. Now in the triangle AOB, what happened? You see, yeah, my dear student, you see here we get this AO as the 15 centimeter half of AC. Again, OB as the half of BC as 8 centimeter, because BD given as 16 centimeter and AC as 30 centimeter, isn't it? And angle AOB, angle AOB will be 90 degree. Once again, this will be 90 degree. Why? Because once again, please listen here. The diagonals of the rhombus is bisecting perpendicular, or we can say that once again, listen here. The diagonals of the rhombus are perpendicular bisectors. Means they perpendicularly bisect each other. Perpendicular means forming 90 degree. So angle AOB will be 90 degree. The angle here is 90 degree. All the angle will be 90 degree. Here four angles are there, isn't it? Inside here or in the center, they will have 90 degree. Okay, this one. So by Pythagoras theorem, we get here AB square. Now this when AOB, the word O, when O is 90 degree, then AB is hypotenuse, isn't it? Then we can apply the Pythagoras theorem, that is AB square is equal to AO square plus OB square. That is 15 square plus 18 square, that is equal to 15 square, we are having 15 15 is 225 plus 18 square, that is 8 is 64, and together we get here 289. So AB square is equal to 289 we are having here, isn't it? And then AB, we are going to get the AB. AB is the side of rhombus, and the side of rhombus is equal. All are equal. The sides of the rhombus are all equal. So if we get one, now we can get the perimeter, isn't it? Yes. Now you see here, rhombus and the square are having same property, that same property, that is the sides are equal. So we need to find out one of the sides. So here the AB we can find out by the Pythagoras theorem. Now AB is the hypotenuse. Now the hypotenuse, the square of the hypotenuse is equal to the sum of the square of the other two legs, isn't it? By the Pythagoras theorem, that means AB square. AB square is equal to AO square plus OB square. Again, so O OA square is 15 square and OB square is 8 square. So 15 square is 225 and plus 8 square is 64. 8 is 64. Then by adding these two we get here 289. So AB square is equal to 289. That means AB is equal to, square will bring to the other side, then we will write as square root. So AB is equal to root over 289. So 289 we will get as 17 centimeter, or 17 is the square root of 289. So how we find out the square root of this 289 is by prime factorization. Okay, by prime factorization we can get that 17. So we can try this. Okay, in the other time when we have interactive class, I will show you by writing them. So here you see, my dear student, AB is equal to root over 289. So 289, the square root of 289 is 17. So AB is 17 centimeter. Means the side of the rhombus is 17. Then you know what is the perimeter of the square. Perimeter of the square and the perimeter of the rhombus are same, because all the sides are same. That means 4 into sides. Isn't it? 4 sides. 4 sides. If you add all these 4 sides, you will get the perimeter. That means all the 4 sides are same, and four sides are there, so 4 into side, 4 into side, that is 4 into side, and then 4 into AB. Okay, AB. So 4 into AB. The perimeter of the rhombus will be 4 into AB, and the AB is a side, so 17 centimeter we get here. 4 into 17 centimeter, that is 68 centimeter is the perimeter of the rhombus. And here we finish finding out the solution of the question number 8. If you have any doubt, anything to ask, you can just put a message in my personal WhatsApp or in the group WhatsApp. Then we will discuss on your difficulty points of these solutions of 6.5. Again, we'll see. Okay, so let us see the next part of the chapter. Now here comes the end part of the chapter, and before we end the chapter, I will just put a glance of the chapter now. So let's go to the next part. This part actually it should become out before. Now here, please, this line please remember once again. Please uh, understand this line. We know that the diagonals of a rhombus bisect each other at right angles. So when they are intersecting, when the diagonals are intersecting, they are bisecting and they form right angles at their point of intersection. Okay, that's what I understand. So with this, let us go to the next part of the lesson. Now, my dear student, here we come the end part of the chapter and the chapter at glance. So, what we have studied, what we have discussed on this chapter, let us see together here. My dear student, first of all, the six elements of a triangle are its three angles and the three sides. So, there are six elements of the triangle. So, the three angles and the three sides are the basic elements of the triangle. Okay, then the line segment joining a vertex of a triangle to the midpoint of its opposite side is called a median of a triangle. A triangle has three medians that we should not forget. Okay. Now the next, the perpendicular line segment from a vertex of a triangle to its opposite side is called altitude of the triangle. A triangle has three altitudes. Yeah. Like the median, the angle is also having three altitudes. So what is the altitude? Altitude is also called the height of the triangle. Okay, and it is a perpendicular line drawn from a vertex. Now next, an exterior angle of a triangle is formed when a side of a triangle is produced. Now, an exterior angle of a triangle, exterior angle of a triangle is formed when one of the side is produced, extended. Okay, when one side of the triangle is extended, then we got the exterior angle. At its vertex, you have two ways of forming an exterior angles. Yes, two ways. Means two directions that you can extend the side. Okay. Next, a property of exterior angles. What is the property? We have learned that the measure of any exterior angle of a triangle is equal to the sum of its interior opposite angles. That you have to understand this. Okay. Next point is that the angle sum property of a triangle is the total measure of the three angles of a triangle is always 180 degree. That you should not forget. And next point we have discussed is that a triangle is said to be equilateral if one of its sides has the same length. Means if all the sides are same, then it is called equilateral triangle, and an equilateral triangle has its angle as 60 degree. Means all the uh, angle will have the same degree, that is 60 degree of every angles. Next, 8. A triangle is said to be isosceles if at least any two of its sides are of same length. Means when you find that two sides of a triangle are same, then it is called isosceles triangle. Then the non-equal side of an isosceles triangle is called its base. The base angles of an isosceles triangles have equal measure. Once again, the isosceles triangles is a triangle having two sides equal and the other sides is called base, which is not equal, is called base, and the angle forming on the base are same in the measures. Okay, then next, the property of the length of the side of a triangle. So let us see what is the length property of the length of the side of a triangle. That is the sum of two sides is always greater than the third side. That is Yes, the sum of the length of the any two side of the triangle is greater than the length of the third side. Next, 10. In a right angle triangle, the side opposite to the right angle is called the hypotenuse and the other two sides are called legs. Then lastly, we have Pythagoras property. So what is Pythagoras property is also given here. In a right angle triangle, the square on the hypotenuse is equal to the sum of the square on its legs. That is what we have just discussed before, isn't it? So these are the points that you have to remember and you have to uh, go through it again to memorize yourself what you have learned from this chapter at the glance. So with this, we come to the end of our session and also end of this chapter. So we'll meet again in the next video. Till then, have a nice day, and once again, I'd like to thank you. Once again, I would like to thank you, everybody. Thank you once again for watching my video. So we'll meet again in the next video. Till then, bye bye, all of you.